Hello, everyone. All right, so where we left off a few seconds ago, this is a brand new stream, so I can split this into multiple sections. Last time we talked about, oh God, we talked about so much. We talked about my plan. What are we gonna do? Talked about what a computer is, what type of computers are there. We talked about what's inside a computer, how does everything work, from the CPU, memory, hard drive, RAM, VRAM, and all that. We talked about the different types of memory, how fast they are. Well, not the different types of memory, but essentially server is slower, HDD, RAM, cache, registers are faster, right? Which is the fastest? And then we talked about how do we start programming, what's an IDE, what's a compiler, assembler, linker, all that stuff. And finally, we talked about the graphics drivers and the GPU and how that kind of works, right? We covered all that, which is kind of cool. There's a lot more stuff that obviously involved, right? Uh, Especially on the GPU part of things, and also on the CPU part of things. This is kind of your introduction to, hey, this is how everything kind of works. Hello, welcome, right? We've explained all this, right? Which is kind of cool. I'll have a second lecture at some point to do more in depth or to go more in depth on every single topic here I talked about today. That's kind of your introduction. All right, without further ado, we can start programming, right? Excited, prepared. Uh, is this article any help? What is this? Mac OS, operating systems, hardware, programming languages. The hell is this? No fucking idea what this is. Sure. There's a bunch of there's a bunch of things I still want to talk about. But this is a good article actually. Kind of surprising. I stumbled upon this when I was trying to do things. Right? So we'll cover all of this. Well, in detail. But I mean we covered all this, but we'll cover it in a lot more detail later on. Right? Which is kinda cool. Alright, let's actually jump into programming. We've been delaying this. We talked about hardware. We want to program. That's where we're here. Let's do it. Okay, so I showed you how to download Visual Studio before, right? I have a video on my YouTube channel on that, so you can check it out. So after you open Visual Studio for the first time, click on Create a New Project, right? It's gonna ask you what language you want to pick. So we want to go with C++. That's the language we're gonna go with. We want to go with Windows as a platform. And then we want to select empty project, right? Make sure you select empty project. We want to do a fresh start, no code inside, right? And then click on next. Name your project. I'm gonna call it RPG game. I prefer you name your project without any spaces, right? So and lowercase RPG game. So you can do RPG dash game, right? We can do capital. So RPG dash game, something like that. Just try not to have any spaces in your project. Sometimes not fantastic. And then press create. All right. I want to go in as much in depth as humanly possible. Right. I want to explain every minute little detail. So bear with me here. This is designed for people who has never used this or seen this for the ever. So if you've seen it before, I'm sorry. Bear with me. Okay, so this is a Visual Studio. Welcome to Visual Studio. This is the application we're gonna use to program or write our software. Right? So, the very first thing, I wish I could reset this layout. Can I reset this layout? Reset Windows layout. Yes. Okay, fantastic. So when you first run or open Visual Studio for the first time, you're going to see this. This is exactly what you're going to see, right? Now, let me talk about the Solution Explorer. So this window over here, right? The Solution Explorer is the window that basically shows you all the project contents. So everything in your project, all the files, all the images, audio, source files, the code, anything in your project will be shown in here. So this is kind of our project explorer. This is where we see all of our files. So this is Solution Explorer. Next, properties. This properties window is window that might be helpful later on. We don't use it much, or I don't think we're gonna use it much, but it might be useful. So it just shows us some properties. So for example, if I click on my project and expand this a little bit more like this, just shows me like the location, the project location, and so on and so forth, right? And you can make the window bigger like this, or smaller, by the way, so you can expand it and do that, right? I would like to explain, so let me get my Epic pen, right? Let me explain a few things, right? Epic pen, here we go. Okay, so, yeah. Okay, so I want to start with this. So this says solution, right? This here, I'm gonna select it. This is your solution. Okay, what's a solution? A solution is the very top project. Well, not top project. It's the thing that contain multiple projects. So for example, a single solution can have your RPG game, it can have your server, your client, your engine, it can have multiple projects. So you can have multiple projects into your solution. Right now we have a single project, which is our game. So this over here, right? This is our project. It's called RPG-game. This is my project, right? And the solution can have multiple projects. In this case, we just have one. Cool. What's next? If I expand my project, I can see there are references, right? We'll talk about references later, right? You can reference other stuff. We'll talk about that later. But what else you can see is that you can see external dependencies folder, a folder that's called header files, a folder that's called resource files, and a folder that's called source files, right? All these things. Now, header files, source files, and source files, all these really, these are all virtual files. That means they don't actually exist on your hard disk. So if I try and if I right click on my project and click on open folder in File Explorer, you'll open my project. This is my project. You can see there's nothing here. It's empty. How are these files, or how are these folders, how do they exist? There's nothing in here. Well, they're virtual, right? Visual Studio creates these folders for you to organize stuff, but they don't actually exist on your hard disk. I don't like that. I don't like that at all. So what I usually like to do is click on this button here at the very top. This button over here, right? This button says show all files. So if I click on it, you'll see it'll show all the files inside my project. And currently there are no files in my project. There's nothing in here. I can make a file, right? If I want to make a file, I can either make it in here or make it in here. Let's make it in both places just to show you. So if I right click here, go to in Windows 11, go to new, select a text file. I'm gonna say code.txt, right? If I go to my project and I click on this refresh icon, and expand this, you can see there's code.txt. So this is an actual file in my project, which is over here, right? So if I delete it, I go here, refresh again, click on refresh, now it's gone, right? So this shows you what's inside your project. If I click on the show all files again, I'll see the virtual folders which don't exist, which I don't want to see. I don't like that view. So I'm gonna remove them by clicking on this show all files. So I see the actual, what actually is there, right? You can also add like you can add a file in here. I'll show you how to do that later. But all I want to explain to you here is a solution can have multiple projects. And we have a single project right now called the RPG game. And this will show us all the files inside. And currently there are no files, right? There are these 3 files, but these are the actual project files, which makes the RPG game. These 3 files are the actual files that makes the RPG game project, right? So currently our project has nothing. There's nothing inside it. So that's the Solution Explorer. We're going to use it a lot. It's really important and exists. You can make it bigger and smaller. Now, I personally like this window on the left of my screen. I don't like it to be on the right, and I can move it. The way I do that, you see this blue bar? It says Solution Explorer. If you click and hold your mouse button on the blue bar, so left click with your mouse button and hold and move your mouse, you can see I'm holding my mouse button right now. You can see I can place it in multiple places. I can place it in the top here. So you can see it makes a highlight of how it looks if I place it on the top. I can place it on the right side. All right, I can place it in here, in here, in here, in here, or here. I can place it in the bottom. I can place it like this, like that, like that, like that, or like that. Or I can place it over here. Right? So I can have it in multiple places. So as an example, I'm going to show you if I place it over here. So you can see it's going to occupy this entire space. If I click and hold on the Solution Explorer, let's say I want to occupy the bottom part. You can see it occupies the bottom part. Click and hold, left part, occupies the left part, which is kind of what I want it to be, right? But not this big, so I'll make it a lot smaller. Right? There's no difference between this and this as far as I know. Yeah, zero difference, right? So you can see I like it this way. Now I like this window below, right? So I'm gonna, again, click and hold, go to the left side, right? And then go to the bottom side here. I can see it's below and I can make it smaller like this. That's how I generally like my layout from Visual Studio. That's how I want it to be laid out. Cool. All right, so now that we set up the layout, there's a bunch of things here like file, edit, view, get, all of that stuff. We'll go through these later on. I just want to jump in and code, right? That's all we're here to do, code. I'll introduce you to everything else as we go. Now, my project is empty. There's nothing in my project. How can we start writing code? Well, if you right-click on your RPG game project, not the solution. Again, make sure you differentiate between your project and solution. Solution is up here, project is down here, right? Right-click on your project, go to add, new item, okay? So add new item. You will see this window pop up. And there's multiple types of files. There is C++ file, header file, C++ class, and C++ module interface unit. We're going to go with C++ file. I will explain what all of these are later on, what they do, but for now, I'm just going to go with C++ file.cpp. Make sure you name it. So the name, I'm going to name it main. Small m, main, right? You can either double click on C++ file or click on add. After you name it, make sure you name it, right? I'm just going to double click. I usually just double click. You can see it created a file on the left side called it main.cpp. And it opened it, like here in a tab. You can see the tab up here. Now you can close this tab by clicking on X and close it. Just like a Chrome tab, if you have multiple Chrome tabs, you can close them. If I want to open it again, double click on it, it'll open. If I click on it once, it'll preview it, and you can see the tab is on the left. This is a preview, meaning if I click on something else, if I have a different file and click on it, it'll disappear. So I'll show you an example if I create two files. So let me create two files here. And here I'm going to create another C++ file. I'm going to call it hello. Don't create this file. This is just for demonstration purposes. I'm going to click hello, right? And hello, I'm going to say hi, save it. And main, I'm going to say main, save it. Now, I'm going to close both of them. If I click on hello, this is a preview. You can see it opened up hello on the right side and says hello. If I click once on main, it's going to show main. If I click once on hello, it's going to show hello. So this is just a preview. If it's on the right, it's a preview of the file. If I double click on it, this is the file open, so it goes to the left. If I hover over main, it opens a preview on the right. If I double click on main, now both of them are on the left. So one click is a preview. Double click is the file itself that I can use. Now, you can close a file by clicking on X, right? I can close it like that. Or you can click with your middle mouse button. So if I click with middle mouse button on the tab, it closes it, which I usually prefer doing. It's a lot faster. So open it, close it by clicking your wheel. Like you have a wheel on your mouse. If you click it, you can click your wheel usually. If you click your wheel, it will close it. Okay, I'm going to delete hello because, well, hello is, so to delete a file, you can right click on the file, click on remove. It'll give you two options. Would you like to remove it or delete it? When you remove a file, it just removes it from the project, but it still exists on your hard disk, right? If you delete it, it just deletes it like forever. All right, I'll show you an example. I'm going to delete hello. So if I go here, so this is my, let me put this side by side. Okay, I'm gonna right click on hello, click remove, and then I'm gonna click delete. Look what's gonna happen on the right side here in hello. Hello is gone. I clicked on delete. If I right click on main and remove, and I only click on remove, it's removed from here, but it still exists here, right? And you see this icon, this like a red icon. That means this file exists in the, like it exists in here, but it's not part of the project. It's not gonna be compiled by the compiler. So if I want to include it again, I can right click on it and say include in project. So these are just a bunch of things you can do. I'm gonna clear, I'm gonna delete the main and just save it, right? So that's remove, right? So I want to stay with main. One thing you want to do is you want to save your file, right? How do you know if your file is saved or not? So if I type hello, a few things are gonna happen. A yellow line gonna appear on the left, right? And that means it's not saved. This line was not saved. You can see there's an asterisk over here at the top, right? That means it's not saved. You can save it by pressing Control S. I saved it. Or you can click on the floppy disk, single floppy disk. That means it's gonna save only this file. If you have multiple files that need to be saved, you can click on the two floppy disks that says save all. I hope you know what a floppy disk is. If you don't know what a floppy disk is, God, you're way too young. But there you go. You can save multiple files, right? Actually, if you're watching the stream, let me know if you know what a floppy disk is. Cool. Well, if you're watching the video. Okay. So I'm gonna, this is main. There's nothing inside it. It's empty. Line 1, right? We're gonna start writing some code here. So let's get started. All right. So the first thing I'm gonna write is, the first thing I'm gonna write is say include the pound sign, and say include iostream int main return 0. All right. Now, a few things you might have noticed while me writing some code. The first thing is, when I start writing code, you'll see this drop-down menu showed up. This drop-down menu is a way for, it's Microsoft way of helping me to program. It's like autocomplete, right? It shows you all the different things you can use. So it's very helpful when we're programming, and this is called Intellisense. Intellisense allows you, or shows you this box. It's like a smart way or an autocomplete to kind of help you program. The next thing you might have noticed, if I start typing stuff, you might see a red line under some stuff if it's wrong, not spelling wise, right? Visual Studio doesn't care about spelling. This line, the red line, means the computer doesn't understand what this is, or Visual Studio doesn't understand what the hell this is. This is not, WEF is not C++. It's like, the fuck you talking about, bro? Don't know what you're talking about. So it gives you a warning. It shows you a red line here, and it also shows you a red line there. Even though this line is not wrong, but because this line is above it and it's wrong, then it also shows you the next line is also wrong. If I put this line at the bottom, it's just going to show you only this line wrong. Now this is a perfect segue to say that your computer, when it's reading code, it reads it from line 1 to 10. So it starts at line 1, then it goes to 2, 3, 4, 5, and so on to 10. So it reads it from top to bottom. So if there's an error in the previous line, then most likely there's an error in the second line. Or it's going to show you an error on the second line or the next line. Even though this line is completely fine, like it's a legit line of code, but the previous line kind of messed it up, right? So if I delete the previous line, also the error is gone over here. Because that's something to kind of keep in mind, right? Okay. So this green line just means I've saved my file. All of these lines are saved. If I press space, you can see this line is yellow. That means this line is not saved, so I can save it Control S. Anyways, what did I just write? What is all this? Well. There's something I didn't quite talk about last stream, which is going back here, right? Going back here, do you see the things we need? We said we needed the text editor, we need a compiler, an assembler, and a linker, right? 1, 2, 3, 4. And all of these, whoa. That's a thick line, hold on. Still a thick line. Good enough. And all these applications, right? Text editor, compiler, assembler, linker, all these guys exist in the IDE, which we just downloaded and installed. Now, one thing I didn't mention is between the text editor and the compiler, something exists over here, right? And this thing is called the preprocessor. The preprocessor. So go like this. What is the preprocessor? The preprocessor runs before the compiler. The preprocessor is another application, small application. What does it do? Well, essentially, by the way, I'm watching Seinfeld on Netflix. Don't judge me, okay? It's actually a fantastic show. Absolutely love it. I've seen it like a million times. But I digress. Moving on. A preprocessor. What a preprocessor? A preprocessor is an application that basically what it does, if it sees a hash, do you see this hash over here? Or pound, or God fucking damn it. Hashtag. I hate using the phrase hashtag. That's why I was like, God fucking damn it. It's a pound. It's a pound, okay? It's not a hashtag. But whatever. If it sees this hashtag, right? I am now communicating with the preprocessor. And I'm telling the preprocessor, hey, this preprocessor has a command called include. So I'm saying, preprocessor, include this file. This file is called IOStream. So any command that starts with the hashtag or the pound, I'm going to say pound for moving forward, if it sees this pound symbol, right, it's going to execute whatever thing you want it to do. So there are multiple preprocessor commands. There's pound include, there's pound define, there's pound if, and you can see there's a bunch of them. There's define, elif, else if, if, like a bunch of things. We'll talk about these later on. But anything that starts with the pound, it's a preprocessor command. In our case here, it includes IOStream. Okay, so how does this preprocessor work? Well, essentially, what it does, it replaces one word with another word. That's what a preprocessor does. All it does is literally replaces one thing with another, and that's it. So when it sees hash include IOStream, what it actually does, it goes into this file. And if in order for you to go into this file, press and hold control. So press and hold control, and this will turn into like a URL you can go to. If you click with your mouse button, left mouse button, you'll go to the file. So again, click and hold, or press and hold the control button, and left click with your mouse on IOStream. It'll take you to the file, right? So what this include IOStream does, it replaces this line with all the content of this file. So all of this file, all of this, it's gonna be copied, Control C, and it's gonna be pasted in here. And you can see this is our main function. We'll talk about this later on. But it literally just replaced IOStream, or sorry, it replaced include IOStream with the content of the file. That's what a preprocessor does. All it does, replaces one word with another word. In this case, one word with a file. Now notice, inside IOStream, there's more include. So there's include IS or iStream. So we include IOStream, which also has iStream. So if I go to iStream, it's going to copy everything in here, and it's going to replace it with this line. So now we have more code. And so it's going to look for more include commands. You can see our code is now 1,000 lines of code, right? And this will work. This will run. This application completely runs fine. If I press play and run it, it should run without any issues or any problems, because we literally just did what. See, it ran. No problems. So we literally just did what the preprocessor is supposed to do, which replaces one word with the other. So here, another include. If we go to this file, we Control A, Control C, and copy it and replace it with this. So now our program is 2,500 lines of code. You can see our program is pretty big, right? So that's what the preprocessor does. So I'm going to Control Z everything, so you don't freak out, right? So when the preprocessor runs, and it's the first thing that runs, in according to this drawing, or according to me, and according to the rest of the world, I didn't just make this up, but I digress. The first thing that happens when you write code, the first thing that's going to run is the preprocessor. It's going to replace words with other words, or words with files, right? After it runs on your entire application and it does its thing, your code is going to get compiled, right? So that's just the thing, one of the things that I didn't talk about last time. Cool. So that's what include IOStream does. It includes this file in our project, or in our code. And why do we need this IOStream? Well, we want to display things on the screen, and IOStream helps us do that, right? Cool. Hope that made sense. Next, this function called int main, or this is a function, right? This entire thing is a function. So what's a function? Well, a function is, you can think of a function as something that does something. Let me explain. So for example, I can have a function that's called drive car. What this function does, it drives the car. So if I take this function, give it to a human can drive a car. If I give this function to a dog can drive a car, right? So a function is just a bunch of instructions that gets executed by the computer, right? A function is just a package. It's a container. It holds code that gets executed by the computer. I can have a function that's called kill, right? A kill function. So I can give this function to grandma. I can say, hey grandma, use the kill function, grandma. All right. Now I didn't specify what to kill, so grandma could go kill, I don't know, kill another person, which would be a whole disaster. She would go to jail, and then she'd have to go to trial, and then have to pay for a lawyer, and all because we gave grandma the kill function, which is, not good, not very good, if you'd ask me. But I digress. You can make a function and give it to other things. I can make the kill function be given to an enemy, so an enemy can kill whatever, anything, right? Anything I want. So a function is just a container. It contains code, and this code is executed on the computer. Now, what is this function? This function has a name. The name of the function is main. The name of the function is main. That rhymes. Cool. This function has a name, and the name of this function is main. What is the main function? Well, going back to the operating system, or going back to Windows or Mac or Linux, right? All these guys are operating system. The operating system will go and tries to, whenever it runs our program, the first thing the operating system will do, it will try to find this function, the main function. This is the entry point for the operating system to run our application. So Windows, whenever I click on an application, double click on an application, Windows will go and look for this function, exactly this name. If it's capital M, I'm gonna get an error. If it's capital, like if it's called Wayne, it's gonna be an issue, right? It has to be called main. Has to be called main, because the operating system, and small letters like this, because the operating system will go and look for this function to execute it, to start our program. So our program, our entry point is over here. This is where our application starts. And if the operating system of Windows or Mac or whatever operating system you're running, if it can't find this function, it cannot start our application. Okay, so our function is called main. It has these two brackets, open and close brackets. Now, every function has these open and close brackets, and we'll talk about these brackets later on. But another thing our function has is this blue int. What is int? It's blue. It's here. What is this? Well, this is a data type, and we'll talk about data types later on. But for now, you can what I'll tell you about this is int stands for an integer. And if you don't know what an integer is, it's a number. It's a full number. 1, 2, 5, 6, minus 10, minus 11, minus 12, minus 100, minus 5 billion. These are all numbers, right? And int represents a number. So I am saying this function, okay, will return an integer. And if you don't know what return is, I'll explain it in a few seconds, so don't worry about it now. But for now, int is an integer, right? Just keep that in mind. All right, what is this function doing? Well, the function is returning number 0, right? As you can see, the word return and the value 0. Now, why not 1? Why not 2? Why not 3? Why not 4? Why not return 600? All right, minus 600. Well, whenever we say return 0, we are basically telling the operating system Hi, hey TQ. What's going on? Teaching some C++. You're more than welcome to join. So, what I'm telling the operating system here is, hey, once you open the program, right, and once you execute the program, when you're done, you can I basically tell it to return 0, meaning, hey, this program executed without any errors. This program has finished without any issues. So 0 just indicates no issues. All good. No problemo. Right? As the Spanish would say. Is no problemo Spanish? I don't know. Whatever. Doesn't matter. The point is, return 0 means, hey, everything went well. If I say return 1, 1 could be an error code to the operating system. It could mean something wrong happened. 2 could be an error code. 3 could be an error code. Minus 100 could be an error code, right? Return 0 means all good. Peachy. Cool. Now, we said that this function is returning an integer, right? What is returning? What does that, well, what does that mean? Well, when you return something, right, you basically say, or let me rephrase this. Sorry, let me rephrase this in a different way. A function can have multiple inputs and can return multiple things. So if I go back to my lovely diagram that I created here, right? Let me find this space here. Let's go over here. Okay, so this is my function. It's a box. It's a nice box, right? Let's say this is kill grandma. I don't like grandma. She's kind of annoying. I kind of want to kill her, right? I'm violent. I know. It's fine. Don't worry about it. Let's say kill grandma, right? This is a function. It can take an input and it can give you an output, right? The input, for example, is a shovel. I love programming. Grandma can have a shovel, right? And she can take the shovel to kill someone. All right, the output would be dead body. All right. And so a function has an input and it gives you an output. Whenever we say here, I know, right? Poor grandma. Whenever we say here return an integer or return int, we're basically returning a value. And in this case, we're returning it to the operating system. So when this function executes, we're saying, hey, return, sorry, I hit the mic. I say, hey, return 0, meaning return with no issues, right? So this is a function can return something or it can give you an output. Now for an input, a function can take an input or can take no inputs, right? A function can also return nothing, right? But in our case, if I look at my code, in my case, my function returns an integer. My function returns an integer, right? Which is return 0, but it takes no input. How do I know it takes no input? Do you see these two brackets that I told you about before, or we looked at before? This is my input here. This is where I take inputs. And right now, I'm not taking any input, 0 inputs. But I am returning an integer. I'm returning a value, right? So that's essentially what a function is. We'll talk, or we'll dive in a lot more in depth. We'll talk about functions in a lot more detail later on, but that's kind of your 101 about functions. Cool. All right, so a quick recap. IOStream just includes the file into our project. We have a function that returns a number and takes no input, right? This number that it returns to the operating system, and it returns 0 and says, hey, everything is cool, no issues. If my application finishes, it tells the operating system no issues, everything is good. Right? So right now, if I press play, and I can execute my program by pressing play here. And if I do that, nothing happens, right? It opens this window, and my program literally did nothing. My program is currently very useless, completely useless, right? Which is yeah, which is kind of cool, right? Now, this, by the way, is called the terminal, right? If you've never seen this window, this is the terminal, and this is where we're gonna see our game. Well, not really. We're gonna have a window where our game is gonna be displayed, but this window is called the terminal, and it's very useful. We're gonna see some useful information like warning messages, error messages, whatever information we want to print on the screen. It's kind of useful. All right, how about we print something on that screen? All right, how about you do that? Well, you can do that easily if you type std cout hello world, okay, and then std endl. All right, that line has a lot of information. Let's start with std. STD doesn't stand for what you think it stands for. It's not sexually transmitted disease. STD stands for standard. Okay, standard library. That's the C++ standard library. And STD is a namespace. We'll talk about namespaces later on, but you can think of a namespace right now as a way to organize your code. Right? I'll give you an example. Let's say you're going to the library. All right, and you want to read the first book of Harry Potter and Chamber of Secrets, I think. Now, there are two books in the library. They're both called, let me just draw this for you. Sorry, Grandma. All right, so I have a book called Harry Potter, Mr. Potter. That's another book, Harry Potter, right? Both books have the same title, same exact title. If you go to the librarian and tell the lady, hey, I would like to rent, or I would like to take the Harry Potter book. Now, she'll be a little bit confused because there are two books called Harry Potter. However, one is written by J.K. Is her name J.K.? J.K. Rowling? Yeah. And the other book is written by David. And David is he's not a nice person. He basically stole the title, right? But we have two identical books. Well, not identical. Two books with identical titles. However, the contents of the book are different. Okay? How would you tell the librarian? How would the librarian know which book you want? You want this Harry Potter or this Harry Potter? Same titles. Well, you can tell the librarian you can say, hey, I want the Harry Potter book written by J.K. Rowling. Or I would like the Harry Potter book written by David. So David and J.K., right, they're namespaces. Namespaces are a way to organize our code. So if I write some code, I can say, hey, this code is using the JK namespace, or this code uses the David namespace. All right, so just a way to organize our code. And so STD is a namespace, right? So for example, if someone uses the cout or has written a function called cout, I can differentiate between that guy function and the standard library function, right? So STD, a namespace, is just a way to organize and categorize our code. That's essentially it. And the way we use a namespace is by using colon. That will become a lot more clear later on, right? All right, so STD namespace, we know that. Great, fantastic. What's cout? Well, cout is part of the IOStream standard library. If I didn't include IOStream, if I delete IOStream, you won't see cout, or you can't use cout, right? And so cout is a function, right? And this function allows you to print something on the screen. Do you remember this black box? This black box over here? Cout is a function that allows me to print something on it. And you can see here it says hello world. All right, if I press play, you can see it here. Cool. Now, this is a special function, or it looks a little bit weird, because I previously, when I talked about functions, I said functions have these two brackets. A function has two brackets. This doesn't have brackets, so what the hell is going on? Well, this is something special you can do in C++. We'll dive deep into that way later down the line. I don't want to confuse you too much, but essentially cout is a function that executes or take an input, take this as an input, right? So, hello world is a string, or you might have seen hello world with double quotes. If you press play here, you won't see these double quotes, right? You just see hello world. So what's up with these double quotes? Well, essentially, double quotes means this is a string, right? A string is a collection of characters or numbers or symbols, right? A character can be a number, symbol, or letter, right? So these all are characters, these are all characters, all these are characters, right? And anything between double quotes is considered a collection of characters or a string. So we call this a string. Now, why do we have to have the double quotes? Well, because if you don't have the double quotes, Visual Studio or C++ is going to think that this is a function. Hello is a function, or hello is a variable, or hello is a class, or hello is something, right? It goes, tries and find it, and it can't find it and gives you an error. Same thing with world, right? So in order to tell C++, hey, dude, calm down, cool it. This is just a string. I just want to print this on the screen. I don't want you to do anything crazy, right? I don't want you to find anything. Just take this, print it on the screen. So we made a string with double quotes that says hello world exclamation mark. So essentially, this string is being sent. You can see these two arrows. This is called the bit. Okay, this is a mouthful. This is called the left bit shift operator. That's a lot of words. Left because it points to the left. Bit because it manipulates bits. Shift because it shifts bits. And operator because it's an operator. Perfect. We'll talk more about operators later on. But for now, you can think of it as, hey, I'm taking this string and I'm moving it to the left to cout. Right? All right, so I'm moving this to left to cout. What about this endl, std endl? And again, std is the namespace. Endl just basically means a new line. So give me a new line. So if I press play, you can see hello world, and there's a new line over here, empty line. If I don't put this endl, so if I remove the endl, and if I press play, you will see that hello world, there's no new line, there's no empty line. Before there was an empty line under it, right? So that's what endl does, which is useful because if I copy this line, paste it again, and say my name is David, right? And then I press play, you will see that's going to say hello world, my name is David. Cool. If I remove endl from here, and I also remove endl from here, you will see now that all of these are on one line. It says hello world, my name is David. So endl is just a way of saying, hey, go to the next line, which is kind of cool. So there you go. So hello world, new line. My name is David, make a new line, which is kind of cool. Right? Cool. That's this line essentially. That's really it. And if you manage to run this code, congratulations. You're a programmer. You're officially a programmer. All right? Cool. So, that's really it. Includes this file. Main is a function. It's the main function that the operating system runs for the first time. Return 0 means, hey, if the program ran without any issues. It's gonna tell the operating system everything is good, no problems. The main function is our entry point, or the operating system entry point to the program, and our program just executes this line of code which says, hey, hello world, print on the screen, or print something on the screen which is hello world, and then print a new line. Cout, this is pronounced, by the way, C out, right? It's 2 words. C out, right? Not cout. Cout, right? And this SCD is a namespace. It's a standard library namespace, which doing printing on the screen, or using STD cout to print this on the screen, which is great. All right, cool. So these are your basics. And so what I can do now is I can do more things, right? So I can duplicate this line, and I can say, hello world, my name is David, and my age is 20, for example, right? So if I run this program, it's gonna say, hello world, my name is David, and my age is 20, which is cool. Now, what if I want to put all this on one line, but with spaces? Well, I can remove the STD cout, because look what's happening. We're saying I would like to print hello world onto the screen and then put a new line after that. So what I can do is I can chain this together. I can say STD cout hello world, put a space here, right? And then print this after, and then put a space after David, and then do this. So it's gonna print hello world space, my name is David space, and my age is 20, right? So if I run this, you'll see that says, hello world, my name is David, and my age is 20. So I can chain multiple strings together to be all printed. So all these guys are being moved to the left with the left bit shift operator. They're all moving to the left to cout, which is kind of cool. You can also do numbers. So for example, rather than putting this 20 in a string, you can do 20 like this. Well, there's no reason you would do that, right? There's absolutely no reason. Later on, it might be a little bit useful, and I'll show you why. But like, it wouldn't matter if you put the 20 inside or outside. So this will treat it like a number. This will be treated in here as a string. So again, it should have the same output. No difference at all. But you can say, hello world, my name is David, which is kind of cool. And if I want a new line, I just do std endl. If I run this, hello, my world is David, my age is 20. You can see there's a new line over here, which is cool. All right, so we printed something on the screen. That was great. That's fantastic. Let's talk about variables and data types. Now, what are data types? Well, essentially, before I talk about data types, I want to show you one thing. You can add a comment in your code. A comment basically is a way of telling your software, or telling C++, ignore this line. So if I put 2 forward slashes like that, and I say hello, C++ will ignore this line. It will not compile it. It will not execute it. It'll in fact, it's not going to be in my code when it gets compiled into ones and zeros, or compiled to assembly, and then the assembler compiles it to ones and zeros. Right? This line is not going to exist. So why do we have a comment? Comments are very useful for other programmers to talk to other programmers, right? So for example, I can basically put a comment that says, hey, David, don't forget to print hello world. We are shipping this software to Google tomorrow for $1 million. Don't forget to print hello world, right? And you can put a threatening message to the program, be like, hey, I'll find you, or I know where you live, or whatever. I'm not saying you should, right? I'm not saying you should, be violent or anything, but you could. The point is, comments, right? They are ignored by the language, right? Which is kind of cool. So you can have a comment. People, and you can communicate as things. You can use comments as a to-do list. So for example, to do, this is common. You can say add function that prints hello world, right? Or you can have a comment that explains what a line does. So I can do std cout hello world std endl, right? I can have this, and I can say this line of code prints hello world to the console, right? And the black thing we saw is called the console or the terminal. So they call the console or the terminal, right? Which is kind of cool. So these are comments. Now these are single line comments. So if I press enter and try type, this is not going to be considered as a comment, obviously. One, because it's not green, and two, because you can see there's an error under it, right? But this is a comment, right? It's a single line comment. What if we want to have multi-line comment, right? So what I can do, /star, right? And Visual Studio will automatically complete it for me. And then I can do star /. So anything written, right? Anything written between this and this, all this is a comment. So I can have multi-line comments, which are cool, right? Also useful, which you could use. So those are comments, and they're useful. So I'm going to use them to explain things to you. Okay. Now, one thing very important before I move on that I remembered, programming is case sensitive. So if you type cout like this, is completely different from cout like that. These are completely two different things. So std is different, all small std is different from all capital std. It's gonna give you an error. It's gonna tell you, I don't know what the hell you're talking about. What is capital std, right? So you need to make sure to type it's, in the right capitalization. Programming languages are capital sensitive, right? So std cout, make sure the same thing with end line e. It's not gonna know what end line capital E, but it knows what end L small l, right? Which is important. All right, so we have hello world, right? We've done all that. Next, let's talk about data types. Data types, there are multiple data types in C++, right? So I'm gonna make a multi-line comment. There's int, which stands for integer, right? There's string, which we talked about, which is just a collection of characters, just the string, right? Int string, right? What else is there? Well, there's float, right? Floats are numbers with decimal points. An integer is a positive or negative number. So I can have -100 is an integer, 6 is an integer, 99 is an integer, 0 is an integer, right? -500. All these numbers are integers. Floating points are 2.5. So this is a floating point. It has a decimal point. An integer cannot have a decimal point. You can't say 6.5. I can't have 6.5 as an integer. That does not work. If you want a number with a decimal point or with a fraction, you have to use a float. And so float is 2.5 or 10. 10 can also be considered a float. So it's 10.0, right? Or -5.1, that's a floating point. Or -0.654321, right? That's a floating point. or 0.7777, that's a floating point, or 10.9999, right? These are all floating points. They can be both negative and positive, right? Which is cool. Next, double. Let's talk about doubles. What's a double? A double is the same thing as a float. Exact same thing as a float, right? It's a number which contains a decimal point, can be both negative and positive. However, a double holds more numbers, or it holds double the numbers of a float. So, for example, in a floating point or a float integer, not a float integer, a float number can have, for example, 5.9999999, right? 7. And so it can hold this many numbers, right? For a floating point. So let's put this in a floating point. A double will hold more numbers. It can keep going, right? So a double contains double the numbers of a floating point, which is kind of cool. Thank you, TQ. I really appreciate that. Right? So, double is the double amount of data inside a float, right? We don't use double. Rarely. We rarely use doubles in video games, just because it takes double the memory or double the space, and we usually don't need that much precision, or we don't need that many numbers, right? A floating point works just fine. So floating point is faster and it uses less memory. So we're just gonna use floats. But I just want you to know that doubles exist. All right, what's next? We have a char. A char is a character, a single character, like 5, or H, or B, or underscore, exclamation mark, or percentage sign, right? These are all characters. And it's very important whenever you write a character, you surround it with a single quote, right? These are all single quotes. This is a character, this is a character, 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 and character, right? Even space. Space is a character. Oops. This space is a character. It's considered a character, right? Single quotes are characters. Double quotes are string. So a string is a collection of characters, which are these guys, right? So there you go. Next is a boolean or a bool. Well, a boolean is just true or false. So for example, I can have a boolean that says, did grandma kill Timmy? Right? True. Did grandma kill David? False. Right? Is game over? Is the game over? True. Am I dead? False. Right? So it's just true or false, true or false, true or false, right? What else? What other data types are in C++? There are a lot of data types in C++, but these are the basics. I don't want to overwhelm you with too many data types at the beginning. But these essentially are the building blocks of creating variables, right? If you don't know, we haven't talked about variables yet. We'll talk about it in a second. But these are all the data types that exist. So you can make a function return an integer. You can make a function return a string. You can make a function return a float, double, char, or boolean. You shouldn't for the main function. So that's really important. For the main function, you should only make it return an integer. But I'm saying if you create your own function later on, you can make it return an integer or a string or a float or so on and so forth, right? But for the main function, it has to return an integer. All right, so these are data types we have, right? Each data type has a size, right, in bytes. I don't want to get into that now. We'll talk about it later in more detail. So let's create a variable. What's a variable? Well, if you ever taken a math class and you didn't drop out of school, and I don't want to keep going with that, but if you ever took a math class, right, you might have heard of the variable x or y or z or a or b or c. These are all different variables, and a variable essentially holds a value. Think of a variable as a box. So if I go to here, this is a box, right? It's a variable. This box has a name. It's called x. X can hold the value 10. So if I say print x, it's going to print number 10 because x is just a name for the box of 10, which holds the value 10. For example, your name, your actual name as a person, right? If someone is called David, this is a variable, right? David referred to this person as a human, right? If I call David, I expect David to look at me. And I expect to punch David in the face because I really, really hate David, right? So David is a variable, right? The value of David is the guy who answers to David. Let me give you an example from a video game, right? I have another box. This box is a variable which has the name health. Health variable contains a value of 100. Let's say this is the player health. So the player can have a health of value 100. If I ever say, hey, I would like to print health, it's going to print the value 100 because health contains 100. And so these are essentially variables. Variables, they have a name and a value. This variable has the name health and it has the value 100. Okay? Now, a variable can have a data type of an integer or a data type of a string or a float or double or char or boolean, right? So with that in mind, let's try to make a variable, right? So all video games, they have health as a variable. So first we need to think, what data type does this health hold, right? Does it hold a number? Does it hold a number with a decimal point? Is it true? Is it false? What is it? Well, health is a number, and I'm gonna decide that it's gonna be full numbers. Health cannot have decimal points. So the first thing I type is the data type of my variable, and the data type of my variable is an integer. Next, I type the name. So what do I name? What do I want to name my variable? I'm gonna name it health. Now I want to give it the value equal 100. Now, if you've noticed, I put a semicolon here, and I didn't talk about semicolons, right? So semicolon indicate that this is the end of the line or end of the statement. This is a statement, and this is the end of it. This is a statement, and this is the end of it. This is a statement, and this is the end of it, right? So that's what a semicolon means. So I've created the variable called health. This variable has a data type of integer and contains the value 100. Cool. That's my first variable. Let me make another variable called string, or the data type string. The variable name is name and equal David. All right. So I've created the data type. I created the variable called name. This variable has a type of string and a value of David. Now you will see there's an error here because string is technically not a default data type in C++, right? String needs the std. You have to say std string because string is in the I stream. It's not a default data type, right? All right. So what I would like you to do as an exercise, I would like you to create, where's my thing? Here. Okay. I would like you to think of different stats in video games. So in video games, there's health. Oops, keep making it small. There's health. Too small. Health. There's damage. There's I don't know, speed, movement speed, attack speed, right? All these things exist as stats in video games. So I would like, and name the player name, right? So what I would like you to do is create a variable called name, create a variable called health, create a variable called damage, create a variable called speed, create a variable called attack speed, and give them the appropriate data types and give them the appropriate values, right? As an exercise. So always remember, the data type is at the beginning. So here, let's say data type at the beginning, the name of the variable, and then here the value. Right? Equal value. Data type, name, equal value. So that's as an exercise I would like you to do. Okay. Now, you can pause the video here. And unpause it when you're done. All right. So I made a variable called health, data type int, value 100. Let's make a boolean. So a bool, I can say bool is dead equal false, or bool is game over equal false, right? So a bunch of bools. I can make a float movement speed equal 10.5 f. Okay. Now this is something I didn't talk about, right? Whenever you type, well, actually it's not an issue in C++, it's an issue in C#. But whenever you type a number for a floating point, you should put an f at the very end of the number, right? And why? Because if I hover over 10.5, it thinks it's a double. But if I put f, it's gonna know it's a float. So essentially, we want to let C# or C++ be like, hey, this is a float, assign it to a float. Nothing bad will happen if you forget the f, but it's a good practice to keep it, because in C# it's bad. If you forget the f in C#, it's gonna yell at you. All right, let's make a character. So char first letter in name equal to D. So for Dave, right? So these are a bunch of things, right? This is a bunch of data types, bunch of variables. So again, you always put the data type at the very beginning, the variable name, and the value, right? So let me show you the exercise, or let me do the exercise that I gave you a few seconds ago. So data type, name, value. So let's start with the name, right? So we have the name, std string, name, David. Done. What's next? Health. I would like health to be an integer. So int health equal 100. What's next? Damage. Damage is also going to be an integer. Int damage equal 100. What's next? Speed. Speed is going to be a float. So float speed equal 10.15. Don't forget the f. Again, nothing bad will happen. It's good practice. What's next? Attack speed. Attack speed is also going to be a floating point. So float attack speed equal 2.5f. So there, I created a bunch of variables, right? They have a bunch of values with different data types, which is kind of cool. All right, what do we do with all of these? Let's print them on the screen, right? So let's do that. So what I'm going to do here is say std cout name std endl. So notice here, when I said print name, I didn't put it in double quotes. Right? I didn't say double quote name, because if I do that, it will print the word name. I want it to actually print the variable name. So what that will do is that it's going to print David here, because name is assigned to David. So see, it says hello world, and then cout name, it prints David, because name holds the value David, which is kind of cool. Next, I want to print the next thing. So std cout health, std cout damage, std cout speed, std cout attack speed. Now, if you don't know how I'm doing this so fast, you can double click on a line to select it. Once you select it, you can press Control C to copy it, or you can right click and copy it, like copy here, but that's much slower. So Control C, both of them, hold Control, and then press the C button. Highlight, hold Control, and press C. Once you press C, remove the Control. Don't hold Control anymore. And then when you want to paste it, hold Control, press V once, and then remove your hand from Control. So that'll Control V. So Control C, Control V, Control C, Control V, Control V, Control V, Control V, Control V, Control V, and so on and so forth, right? So you can practice that if you've never done it before. All right, so let's run our application and see what happens here. So it says hello world, which is this line, right? Then it says David, which is the name. Health is 100. Damage should be 5. Why is damage too high? Let me rerun the application. So health, see, hello world, name is David, health 100, damage is 5, speed is 10.5, and attack speed is 2.5. 10.15, and speed is 2.5. Right? So now I'm printing the values of all the variables. Right? What else I can do is I can say name. So I can say print name, this word name, colon, space, and then name, right? And then I can say print health, colon, and then I can say print damage, colon, and then I can say print speed, colon, and then I can say print attack speed, colon. There we go. Cool. So what that will do, if I run this application, is you can see now it says hello world, and then it's going to print name, David, health 100, damage is 5, speed is 10.15, attack speed 2.5, which is cool. So I basically chained, I said print multiple things. And the reason, you can see I made a space, I put a space here intentionally. If I don't put a space, there's no space. Do you see where I'm clicking here, highlighting in white? This space is going to be gone. So the colon and the 5 are going to be next to each other. So let me show you. So I'm going to take a screenshot of this. Right? So this is our screenshot. Right? Can put it on the side here. And then I'm going to remove the space from all of them. Right? No space. Oops. Right? And then I'm going to press play. Right? Now notice the difference between the two. Look, damage, colon, space 5. Damage, colon 5. There's no space. There's no space for the 100. There's no space for David. Right? There's no space for 2.5. They're immediately next to each other. So that's why I put a space here. Which is kind of cool, right? Now, one thing that's important that you might find a problem with. So, if I press play, right? Let's say I select in the console, like I click in the console anywhere. See how I clicked? Whenever you click, it creates this white kind of bar. Now, if I press play again, or if I change my code, if I remove the space from here, right? Notice how this white bar is still here, right? If I press play again, you'll see nothing will happen. Your application is frozen. Nothing will appear. The reason nothing appears because whenever you click in the console like this and you see a white cube, that means that the application is currently paused, right? So to unpause it, you can right click with your mouse. You can see how after I right clicked, it executed my application. So I'm going to click anywhere in my terminal, even here, anywhere at all. And then I'm going to press space, save it, and run the program again. You can see the application is paused. Nothing is appearing because I have a white rectangle here. If I right click with my mouse, it's going to just work just fine. And you can see I added the space again, right? Another way to do this, right, is if you clicked here somewhere, you can just close it, just close the application, and if you press play, it opens it again, right? It doesn't matter. If you close the application, it shouldn't be an issue. But if you didn't close the application and clicked somewhere here by mistake, and then you press play again, the application will still be paused until you right click, which is kind of important. Now, one more thing you might notice, that my terminal is much bigger than yours, right? It's much bigger, the text is much bigger, and it might be a little bit nicer. And you might want to do that. So how would you do that? If you right click here in the bar, see what it says Microsoft Visual Studio Debug Console. If you right click here and go to properties, you will see that there's options, font, layout, color, and so on and so forth. So for font, I've basically increased the font. I've said 36. For you, I think it'll be 20. So if I select 20 and press OK, you can see the console is much smaller. So I by default said, hey, the font should be 36, which is big so you guys can see it clearly. I can change the color also if I wanted to. If I go to color and say the background, I select a red background, then I'll have a red background and my eyes are not bleeding. And so if I close my application, right, and if I press play again, should have this red background. I don't like it, I don't want it. So you can do properties and just go with black one as usual. If you want like a what is it? Matrix kind of style, can go green. Matrix is black with green. So I can go black background and the text is green. Screen text is green. Not pop-up text. What is pop-up text was white? No, it was black. So if I do this, now it's kind of matrix, which is kind of cool. Go on it like that. Actually, I kind of like it like that. So just make it green. No, just for the video, just to make everything super clear for you guys. I don't want to mess things up. So I'll just go white, the default color, which is kind of cool. Right? Makes sense? Hope that makes sense. If you want to change that, do that. You can click on default. So if you right click and you messed something up. So for example, if you made the text red, the screen to be blue, and you made it this way, right? You can right click and click on defaults, right? And then press OK. What? This should give me default color. Hello? How do I go default? Excuse me? Defaults and properties does the same thing. What the hell? What's the point? How do I go back to default? Excuse me. How do I go back to default? Oh god. Okay, we're gonna have to Google this. Let's Google this. Reset properties of terminal, not terminal, command line to default. All right. Let's see. How to reset? No. How to reset the looks of command line? Let's see. Try deleting the entire. Oh my god! Are you kidding me? Is there really no easy way? Is this what you're looking for? You can check. You are actually joking. All right, ladies and gentlemen, don't mess with this. Because if you apparently defaults doesn't do anything. It's useless. Fantastic. Utterly useless. Whatever. So just make sure you remember these settings, I suppose. Scroll white. No, sorry, black. So this is black. This is whoa. This is black. This is white. Wait. Does this take me to default? Oh, hold on. Let's see. One momento. Okay, so I made it like this. If I go right click on defaults. Nope, that does nothing. Never mind. Alright, so we're gonna make this black. This is white. This is black. The text should be actually not too white. Black. A little bit grayish, right? The text is always a little bit grayish. The background, white is fine. There you go. If I close this, press play. I have to go to properties. Oh, wait, no, hold on. This is the default. I have no idea what's the difference. Does this show you the default color? I don't know how this works, man. All I know is, okay. Okay, so screen background is gonna be black. Pop-up text is gonna be black. Screen text is gonna be gray. Press OK. We're back to the way it was. Jesus Christ. Alright guys, don't mess with this, because apparently if you do, things will be set on fire. Cool. Whatever. Okay. So, that was a detour. Sorry about taking that detour. But there you go. Hope this makes sense, right? What I want you to do is again practice. I'd like you to create a bunch of data types or a bunch of variables with the different data types. Print them on the screen. Play with all that, right? And then that's really it. Just try to play with it, print it on the screen. And yeah, this is all I want to do today, right? I've been streaming for 3 hours. All right. And so what I want to do next time is do more stuff, like jump into making functions and then jump to SFML and set up SFML and to do SFML stuff, right? Cool. I hope you enjoyed this. Again, if you have any questions, if something doesn't make sense, tap it in the comment. If you have any issues, I'll make a video explain. So I think what I will do is if you have a question and multiple people have questions, I'll make a video addressing all these questions and kind of solving them, so people can kind of go and watch it, which would be cool. All right. Hope you